So in this video, I want to take a look at what I did to convert my VT132 into a more standalone unit. So first off, let's kind of look at the overall architecture we have here. We of course have the VT132 sitting here in the middle of the screen. And you can see that I've removed the right angle header here that plugs it down into the RC2014 bus. Instead, I've got a couple of 2x2 pin headers soldered in here. Red is +5, yellow, or black is ground. And in this case, power and ground are being picked up from this position down here to power these two level translator boards. +5 is coming into my card in this case through this cable here. We've got ground and +5 here on pin 3. And one of the cards in my S100 system has some 14-pin dip sockets on it that provide parallel I/O, and those happen to have +5 and ground on them. And all I'll do is just plug this cable directly into that card, into one of those sockets to power the card. Because I'm powering the card from up here and I want the power to get down to the bus, I've got this jumper link in here. This jumper link would enable the modem header here as well. I've just put them both in. It doesn't really matter. But I need, in this case, this jumper in so that the power gets passed from here onto the board and eventually makes it down here. Other things to note here, I've got a PS2 extension cable soldered in here. We'll look at this in a bit more detail in a minute. I've got a couple of TTL to RS-232 level translator boards. I designed these in KiCad, very simple little board. We're picking up the transmit and receive here on the A channel, which is the VT132, and that appears to be coming to this board here. And then we're picking up transmit and receive B on this yellow and orange, and those come over to here. So what this will give me on the machine is a DB25 that would be the input to the VT132 emulator, and then another DB25 that'll be the input to the Wi-Fi modem on the board. So let's dive into all this a little bit deeper. In this picture, we're looking at the back of the case on my Altair 8800 clone. There's this array of 2x4 DB25 punch outs on the back of the case. I've added this little circular cutout here for the PS2 connector to mount into, and what I've got is I've got a serial card inside of the box that brings out TTY0 and TTY1 to these ports. And these are just 9600 baud RS-232. It's an old card, that's the fastest baud rate it'll talk. And in this case, this cable's coming off and going off to a USB to RS-232 adapter, so I can talk to it from Terratim on my computer. But the intent here is I will mount the VT132 VGA plug in this punch out here. The PS2 cable, the jumper cable internally will get mounted here so the PS2 keyboard can plug into this hole. And then I will mount those two DB25 adapters we looked at, the one for the VT132 here and the one for the modem here. And to use, say, the VT132 internally, I'll create a jumper cable that simply connects this DB25 to this DB25. And by putting a cable that jumpers across there, I can then use this internal kind of built-in VT100 emulator. If I want to talk to an actual terminal or something else, I just remove that cable and I plug in here as I normally would. And the same thing with the modem. The modem DB25 will be here, and I can take TTY1 in this case, another cable, and jumper it up. Actually use the modem, or I can remove that cable and take this off to, say, a serial printer. So what this gets into is, for me, because I knew where I was going to mount things and what this looked like, it kind of drove the decisions I made in coming up with the wiring plan. We're looking here at the PC board itself. That right angle cable or connector's been removed, and I've got these little 2x2 arrays in. And in this case, I've got 2 pins here going to ground and 2 pins going to plus. And normally these pins would be picking power up off the RC2014 bus. Instead, I'm using them to distribute power. And then we've got a little 2x2 over here. We've got transmit B and receive B, transmit A and receive A, where B is the modem and A is the VT132. With no changes made to the board, just remove the connector and solder these in place. This picture is meant to represent that I've taken computer style filler plate and I've cut it down, and this gets mounted here. And what this does is it's a filler plate to fill in the DB25 slot, and it holds the VT132 in position. So when this plate's mounted here, like I say, this will go into that DB25 punch out. It gets screwed in via the hole in the slot here. Holds that board in place, and then the PS2 cable just gets pulled up to that circular hole we saw that would be up here someplace. Kind of a closer look at how I'm getting power to the board. Brown in this case is ground, red is +5. Pin 1 on these two connectors is ground, and pin 3 is +5. And like I said, this just goes off to a 14-pin plug here that goes into a dip socket. This, on one of the cards in the machine to bring power to the board. And again, I've got the little headers plugged in here, so the power will make it from here onto the actual board. This is kind of a closer look at that PS2 extension cable. Well, you can see that the cable came pre-manufactured with these pigtails. I just simply didn't mount the PS2 connector and instead soldered the wires directly into the holes they needed to be into. It was pretty simple. These were pre-tinned. I just pushed it through and soldered it and done. Kind of another look here at these little level translator boards. These use Max 232s. It's got TTL on this side, and of course RS-232 levels on this side. In this case, I'm really only using transmit and receive being passed through. There is provision here to add a second level translators out of the chip if you wanted to. I'm not using those. And being a Max 232, it's using 1 microfarad electrolytic cabs. Got 2 of these. One will be for the VT132 and one for the modem. A little closer look at that board. You can find boards somewhat like this available in Tindy and other places, although they tend to be DB9. This is a DB25 converter that I designed in KiCad. I could certainly share out the files. I can't think of what the name of the files are. The files to have it manufactured. I may even create an entry up on PCBWay so that you could pick this board and have it manufactured if you wanted to. Let me know if it would be useful to you. The Gerbers, that's what I was after, the Gerber files. The pre-wired PS2 extension cable, I got it on adafruit.com. It's product 804. You can see here there's 85 in stock. For my application, these pig leads will be long enough to actually do what I need to do. I picked up 3 of these. They don't come with the little screws here to mount them. If you remember, look back on the case punch out. Let's actually go back and look at that. So we'll walk back through the photos here. Oops, went one too far. I've got this punch out here, and the PS2 connector itself comes through the large hole, and then there's 2 smaller holes that those ears go into with small screws to retain it. So if we go back and look at the connector, we've got these 2 screw holes here. Now it didn't come with screws to actually mount in here. You just need a self-tapping screw that'll turn into the plastic to hold it in place, or you can even use a longer screw and a nut, I guess, if you wanted to, but you'll need to provide your own screws to mount that if you're going to do what I did. A closer look at it, it's just a female PS2 connector. If we take a look at the back of the connector, we can see the color coding. Mine came color coded, as you see here, red, green, white, brown, black, yellow. Notice the wider gap here. So it gives you an idea of the orientation here. I'm not going to guarantee every one you buy from Adafruit is the same set of colors, so you just need to make sure that whatever your colors are, you get them to the right spots on the PCB. So with this red, green through yellow configuration here, if we look at the PCB, it follows that same layout: red, green, white, brown, black, yellow. So there are the 6 wires being brought into my board in this case, and I know this wiring works. I've tested this. I guess final thing to look at here is a look at the VT132 board layout itself. And you can see here where I put one of those little 2x2 pin headers. Got 2 connections here for ground, 2 for plus. I've got the second one down here, and that's bringing out transmit and receive B for the modem, and transmit receive A for the VT132. And my little adapter cards simply pick up power from a set of these, and then plug into a set of these to pick up the TTL level transmit and receive. So that's really it. I don't think there's a whole lot else to dive into here. There again is the card is assembled. I just need to mount it. I have tested this configuration standalone like this. It works just fine. I just need to get it mounted in the case and be done with it. I don't know why at the moment the jumpers are on different orientations. I've done something wrong. These jumpers control whether pin 2 or 3 is transmit or receive, and vice versa. Makes the board a little more useful. I believe this is the default position. Doesn't matter. I get this installed. I'll test it. So anyhow, I think with that said, We've covered everything. You can see the little adapter plate here. I did have to put a washer between the adapter plate and the DB20 or DB15 connector here because the printed circuit board sticks out a little bit beyond the front face of the connector. Otherwise, it was putting stress on the connector because it was kind of creating a wedge here because the board sticks a little bit too far. I could have filed that down as well. In this case, I just elected a couple of small washers in here to create a gap so that everything would be flush. You know what I started to say earlier, figure out what you need to do with it, where you're going to mount it, and then kind of come up with your wiring, you know, to meet your needs. So I think I've already said this before. With that said, I think I'll go ahead and end this one here, and we'll talk soon.